Nice having you again, my friends, here on Will EduTech. And in our CSEC Math Exam Past Paper Solutions, in question 10b, part 2c, you will learn how to find the angle of elevation of a point P from the top of a pole from a point M located on the ground. Correct two significant figures. You will also learn how to use your three basic trig ratios, and that is sine, cosine, and the tangent of an angle, and also how to use your calculator when working with these ratios. After watching this video, if you have a question based on any particular topic, you could always contact us through Facebook, and our link is at the bottom of the page here. That's at facebook.com/willedutech. Now, in the previous video, we had looked at solving the part to question B, and that's finding the length of line segment KM, which we found here by using the cosine rule, and we got for our answer 29 meters. So in this video, we're going to be looking at the solution to part C, where they're asking us to find the angle of elevation of P from M, and that's an easy 3 marks. Now, let's just quickly pull this up. So let's just take this up quickly. I believe that's good enough. Now what I did is I had just copied the question and placed it here. Okay, guys. Now let's just look at it quickly. Now they're asking us to find the angle of elevation of P, and if you notice, P is at the top of the pole, the vertical pole that they had mentioned before, and from M. Now if you notice, I've underlined the word from. Now any letter or any point that follows the word from, that's where you're going to position yourself. Okay, so basically if it's from M, if you notice, I have marked the angle theta. I have marked the angle located at the point M theta to identify that that is the angle I'm speaking of. All right, now before we get into solving this question and finding the angle of elevation, let's just quickly look at the simple meaning or the definition of what they mean by when they're speaking about angle of elevation. Now let's just do a quick illustration just for those who may not remember or who is not clear as it relates to angle of elevation. I'll just do a quick illustration here. Let's say we had a building and this is a skyscraper. And what do I mean by skyscraper? Typically some of those buildings you would see abroad, for example in Manhattan, New York, those tall buildings. Okay, remember back in 2001 they took down the World Trade Center, and the World Trade Center, those tall buildings are regarded as skyscrapers. Here in Jamaica you also have skyscrapers also, but they may not be as tall as those buildings. Now let's say we have a few windows there in our skyscraper. All right, now what I'll use a green to bring out my ground. So this green line here represents the ground. Well, really, I have grass here, but usually where skyscrapers are located, you wouldn't have vegetation. It's usually paved areas. Okay, not in all cases, but most cases. All right, guys. So here is my building, my skyscraper. Now let's say Jack is walking towards the building. He went out for lunch and he's coming back to work. Okay, so let's say Jack is some distance away from his building. So here is Jack standing right there. Now let's say on his way back to the building, a bird pitched at the top of the building. So let's just draw a little bird here on the top of our building. If you notice, the bird is right there at the top of the building, and on his way back, while Jack was walking back, he saw the bird at the top of the building. So initially, while walking to the building, my friends, some very important points to make note of. While walking to the building, his line of sight, which is the horizontal line of sight, or what we call the reference line of sight, was focused straight ahead. It was focused straight ahead, for example, straight ahead, and this is a straight line I'm trying to draw here. Straight ahead at the building. Okay, so that would be his horizontal line of sight. Now as soon as he saw the bird, his line of sight changed. Okay, and he started to look at the top of the building at the bird. Now if you notice, my friends, what is happening, and let's just make some quick notes here. Now this now is his actual line of sight. The line of sight, him presently looking at the bird, that would be regarded as his actual, A-C-T-T-U-A, actual line of sight. Okay, line of sight. Now, and as we have stated before, this would be his horizontal line of sight. The yellow line focusing on the building initially. Horizontal line of sight. Horizontal sight. Line won't hold, so I'll just put sight. Alright, now what we're saying, Jack is on the ground and he's looking above at the top of the building. Now what do we mean by the angle of elevation? When standing on the ground and looking above, or when standing below and you're looking above, that angle that is formed between the actual line of sight and the horizontal line of sight is called the angle of elevation. So this angle here that I've marked between the actual line of sight and the horizontal line of sight is what we refer to as the angle of elevation. So let's just make a quick note of that. So this is my angle. Let me just make note of it. This is my angle of elevation. Hope this exercise was a bit useful, all right, in understanding the whole concept of what we mean when we're speaking about the angle of elevation. Now another important point to note is that where the horizontal line of sight meets the vertical building. If you notice, the building is standing straight, so it's a vertical structure. So where a horizontal line meets a vertical line, we have a right angle being formed. Okay, so this is another important point to note, my friends. So basically this shape here that I'm running my pointer along, this boundary, if you notice this shape is now a right angle triangle. Okay, so that's just a critical point to make note of when working with angles of elevation. All right, usually it tends to form a right angle triangle. Now let's quickly move. Now, having said all of that, having gone through that explanation, now let's just quickly look at the diagram. If you notice the triangle, we can just simply take out the triangle PLM, and if you notice, that's a right angle triangle. And as we had made note before, that this angle that is formed between the vertical pole PL and the horizontal ground, which is LM, that horizontal plane, we have a right angle. And if you notice, we have marked our right angle. So basically what we have in triangle PLM is a right angle triangle. So now we're going to look at how we find the angle of elevation from the point M, okay, of P. Now basically what I can do quickly, I'm just going to take out my triangle. I'm going to take out that triangle. It's as if I'm cutting it out. Okay, my friends, so let's just do that quickly. So it's as if I'm oops, that's ugly. Let's just clear that. Yes, so it's as if I'm cutting out my triangle. Okay, so there it is. There we have it. That's our triangle. Now this point would be my right angle, so let's just label it quickly. This point, this angle here, that would be my right angle, and this would obviously be the point L. So that's my point L. At the top I would have my point P, and at the base I would have my point M. And this here, let's just mark that angle. That's our angle theta, the angle of elevation that we're trying to find. Now if we should move quickly, here they gave us the length of LM or ML, and that was 19 meters. So we can just quickly put these values in, and also they gave us the vertical height of the pole, which is 8 meters. So we can just also quickly put that in, or 8 meters. So basically, my friends, what we have here, basically we're just simply finding the angle theta, which is located at M. So since we have a right angle triangle, obviously, and we have two sides that are given, we can use the trig ratios to find the angle theta that they're asking us to find. So let's just quickly make a quick recap on the trig ratios. Now, my friends, here we have our three basic trig ratios that we use in a right angle triangle to find the length of a side or the size of an angle. Here first we have the sine of theta, or the sine of an angle is the opposite over the hypotenuse. The cosine of an angle theta is equal to the adjacent, ADJ, for adjacent over the hypotenuse, which is for short HYP, and the tangent of an angle theta, which is equal to the opposite over the adjacent. Now, basically what we're going to do, my friends, based on the information that is given in this right triangle or in this right angle triangle, what we're going to do, we're going to just figure out which one of these ratios would suit this situation. So let's quickly, let me just show you a very easy technique that you can use to go about that. Now, whenever working with a right angle triangle and whenever using the trig ratios, since they have asked us to find the angle theta that is located at the point M, wherever the angle is located that you're trying to find, always position yourself at that point. So for example, if you notice, I'm just going to draw a little man there, and this is me. My name is Will. So I am standing right there. So basically what I am asking myself now, my friends, is that all the lengths of the triangle, I am asking myself what relationship all the sides of the triangle, that's what I mean by the lengths, okay, all the sides of the triangle, what relationship do they have to the angle that I'm presently standing? Well, obviously we would have known that the side that is across from our right angle, and if you notice my right angle is right there, so the side that's across from my right angle, that would be called my hypotenuse, okay? So that's my hypotenuse, the side that is opposite and across from the right angle, and it's also the longest side of a right angle triangle. Alright, now basically my hypotenuse wasn't given, so I can just simply rule that out. And what I'm going to do is, at standing here, I am asking myself the side that is given, okay, which is for example PL, what relationship PL has to the angle that I'm standing, or to the point where I'm standing. Now if you notice carefully, my friends, PL is really across from the angle, and I'll draw an arrow to emphasize that. If you notice, if I'm standing at the angle theta where I'm presently at now, I would have to look across the right triangle to see the side PL. So another word for across in it when using trig ratios is the opposite. So if it's across from me, it's on the opposite side. So I can simply say PL, the side PL can be called the opposite side, okay? Now again, since that was given, I have to establish that. The next thing I have to establish is what relationship do the side LM shares with the point that I'm presently standing. Now if you notice, the side LM is just beside me. It's beside the angle, or it's exactly beside me, this 19 meters. So I can simply say, my friends, that the point, the line segment LM is the adjacent, because another word for beside when working with our trig ratios is adjacent. So I can say LM is the adjacent side. Now basically, my friends, based on what we have established now, I can simply say, okay, I have the opposite side to my angle and I have the adjacent side to the angle where I'm standing. Now which trig ratio has this combination in it? Now so let's go through. We had made a note over here. So I'm looking for the ratio that has opposite and adjacent. If you notice, sine has opposite and hypotenuse, so obviously that's out. Then cosine would have adjacent and hypotenuse. I'm not looking for adjacent and hypotenuse, so that's out. But when I look at my tan ratio has the opposite and the adjacent, and I have the opposite and the adjacent, so obviously it's my tan ratio I will have to use in this situation. So let's just quickly get into it. Now what we're saying is the tan of theta, this is what we're using. Tan theta is equal to the opposite side over the adjacent side, or the side that is across over the side that is beside me. Now basically theta is the angle that was given, so I can say the tan theta, well, we don't know theta, it's not like they gave us a value. Okay, so we can say tan theta is equal to the opposite side, which is 8 divided by, and I'm just substituting these values over the adjacent side, which is 19. Okay, my friends? And if we should pull out our calculator, we could just quickly, and let me just state this up here. Okay, so we could say tan theta, my friends, tan theta, and I'm simply going to, what I'll be doing here, I'm just simply going to be dividing 8 divided by 19, and we can just pull out our calculators quickly. So my friends, as I have my calculator here, I am saying 8 divided by 19, and that would be equal to 0.42105. And if you notice, that's an irrational number. What I'll be doing, I'm going to be working with 5 decimal places. And why I'll be working with 5 decimal places is because this is not my final answer, and I don't want to work with less than 5 because it may mess up our final answer. Okay, so to 5 dp, basically we can just simply round this off. This would be 1, the 4 would be the 1, 2, 3, 4, 5. So since the 5 it would be in that position, if I notice the number that follows the 5 is a 2, so I'll just my 5 will remain the same. I won't have to trouble the 5. Okay, that's basically it. Now let's just quickly move. So to 5 dp, I have a 0.42105. Okay, 05. Now basically, my friends, if you notice what is happening here, I need to find the angle theta. Now tan is multiplying the angle theta, so basically I need to do the opposite of that, which is to divide through by tan. Okay, so let's divide both sides of our equation by tan. So basically tan would cancel tan, and therefore what I have left over this side would be theta is equal to, and if you notice, the tan is in the denominator, my friends. And let me just point out something very important to you. If you notice, when tan is in the denominator here, the power of tan is really positive 1. And just to do a quick recap of a rule in indices, remember the rule that states, and I'll just jot it down over here, if the base a raised to a negative power, okay, you can always place 1, and this is the inverse rule in indices. 1 over the base and the power becomes positive. Okay, so if you notice, when the power was down here, it's positive in the denominator, but as soon as I flip it and take it up top, because really this is a to the negative m over 1, so really what I did over here was just to flip it around, meaning the inverse, and the power becomes positive when it's down here. So when it comes up top now, it will become negative. So if you notice, if you should make that comparison to my right here, where we have the tan to the positive 1, basically I'll have to take up the tan in the numerator. Okay guys, so when I take it up in the numerator, I will now have tan inverse. My positive 1 in the power will become a negative 1. Okay, tan inverse of 0.42105. So basically I'm taking the tan inverse of that, so we could just simply bring back up our calculator. Now if you notice, this was my answer, so I don't really have to change this value on the calculator. Okay my friends, I am simply going to go to the inverse. On some of your calculators, you may have to press the shift button first, okay, to get the inverse of tan. Press shift, then press tan inverse of your answer. Okay, for me, I'll just press the inverse, this button here, INV, so I'm just going to press that. And if you notice, the buttons have changed, and I have tan inverse, tan to the negative 1 right here. So I'll just press tan to the negative 1, and it gives me my answer, which is 22.83. And again, that's an irrational number, so I'm just going to be using 2dp. Okay, so I have theta is equal to 22.83. So basically, if you remember, and I'll just scroll back to the top just to remind you a bit. If you remember, my friends, from the question that they gave us up top, they said for this part 2, to calculate given your answers to 2 significant figures, and here part C for all of these parts. So basically what we'll have to do now, we're going to have to write our answer to 2 significant figures. Now how do we accomplish that? Let me just a quick recap again. Our answer that we had, that we got there just now, for theta we have a 22, and let me just do it in this little box here. We got a 22.83 3. Now basically, if I'm writing this number to two significant figures, then I'll have to identify this is my first sig fig. The first two there would be my first significant figure, and the second two here will be my second significant figure. Now what I'll have to do, I have to position, since it's two significant figures they're asking for, I'm going to have to position myself at the second significant figure, which is the second two there. Then I simply have to look to my right. If when I look to my right, this number here, now it's a 8 right there. Okay, if this number is great, or if this digit is greater than 5, if it is 5 or greater rather, then I'll have to add 1 to the 2. So basically to 2 sig fig, I would have to add 1 to the 2, so I would have a 23 degrees for my answer. So therefore, I can make my statement now that therefore theta is equal to 23 degrees. Okay, my friends, so you can just simply make your statement since it was a worded problem. So there, my friends, I have made my statement. The angle of elevation from M to P is 23 degrees, and remember, this is correct to two significant figures. Feel free to leave a comment or a question if you're still not sure, and we'll get back to you as soon as possible. Bye bye.